In this video, you will find general information about one-dimensional motion with constant acceleration, including definition of U-turn point. Then we will determine the time to reach U-turn point and its location. Finally, we will analyze the motion of an object in several specific cases, emphasizing the tricky features which one can encounter. Let us consider an object which can move along a straight line. We will select this straight line as x-axis and suppose that at initial moment t equals 0, object has coordinate x0, initial velocity v0, and acceleration a. Acceleration a remains constant during entire motion. At t greater than 0, so during the motion, the object takes a new position which characterized by coordinate x, the same acceleration a, and new velocity v. Position of the object at any time can be described by kinematic equations, which you should know. Here Vx and ax are x component of velocities and acceleration. Most important here are first two equations, and the third one, which doesn't contain t, is a consequence of these two equations and is very convenient for some specific situation. Depending on direction of a and v0, we can separate two different cases. First case is when a and v0 point in the same direction. In this case, x component of these quantities are positive, and it's very easy to find a position and velocity of the object at any time. For this reason, this case is very simple. More interesting is the case 2, where acceleration and initial velocity point in the opposite directions. In this case, the motion happens as follows. First, the object moves with decreasing speed, and then stop at some point xu, and at time tu. We will call this point as U-turn point, and then it moves back, passes the initial point, and moves away with increasing velocity. Such a not complicated motion, nevertheless, sometimes leads to confusion. The students ask how is possible that the object first moves to the right from initial position, but after a long or short time, it appears to the left from initial position. Such questions in most cases arises from ignoring by students analysis of the motion and using for solution of problem only equations. If you analyze the motion, there is no any doubt how such case can happen. Now, let us consider two specific examples of motion corresponding to case 2. First example is vertical motion of projectile. In this case, object moves in such way, and x component of acceleration is equal to negative g, where g is free fall acceleration. The second important example is the motion on a frictionless incline. So the object first moves up, then stops and goes down. If we consider the object at any position on the incline, and then x component acceleration for this motion is a negative g sine alpha, where alpha is an angle of incline. Of course, we can use our basic kinematic equations to solve any problems related to motion, either projectile or motion on the incline. And now we will solve several problems related to the second case of one-dimensional motion. First problem is to find position and time to arrive at the U-turn point. This point is a specific point and is important to know it to make a right solution of various problems. So how to solve it? First of all, we know initial conditions, so we know initial acceleration, initial position, and initial velocity. Now we know final velocity of the object at a U-turn point. Of course, the object will move later to the left, but at this moment its velocity is equal to 0. So we can apply kinematic equations in this form, and we can write initial x components of velocity and acceleration as is shown here. Now the next step we can do with equation 2, because we know final velocity 0, we know initial velocity and initial acceleration. So plugging in these values, we have this simple linear equation for time to arrive at U-turn point, and this time is given by this simple expression. To find position of U-turn point, we plug in this time to the first equation, and by direct calculations we can find this answer for position xu. We can double check this answer by using the initial condition and plugging in them into third equation, which doesn't contain time, and as a result we have the following answer, which of course coincides with the previous. As an example, we consider the following initial conditions. Let's suppose that at initial time x0 is 0, initial velocity is 3.0 meters per second, and magnitude of acceleration is 1.5 meters per second square. Don't forget that in this equation we should use not magnitude but x component of acceleration, so we have to use here, if we plug into equations, the negative value. But in these answers, here are magnitudes of acceleration and initial velocity. So using these two answers, we can immediately get that time to arrive at U-turn point is 2 seconds and position is 3.0 meters. So the problem 1 is solved. And now we consider the second problem. We will find time tf to reach given point with coordinate xf. So the object is at initial position, it has initial velocity given and acceleration. Also we know initial coordinate on x-axis. The goal is to find time tf to reach given point xf. To solve this problem we will use kinematic equations, and first we will look to the first equation, and we know everything in this equation but t, x in our case is equal xf. So this equation has this form. It's more convenient to rewrite this equation in such form, and we see that this is a usual quadratic equation with respect to unknown quantity tf. However, the problem is not so simple, because you know that the quadratic equation can have two roots, one root, and no roots at all. So let's link these features of quadratic equation with physics of the problem. To do this, we will recollect that there is another specific point, xu, and this is a coordinate of U-turn point, which will play an important role in our analysis. Let's consider the first case when xf is to the right from U-turn point. In this case, object is here initially, and the motion looks like this. Object moves to the right, arrives at U-turn point, and goes back. So we see that in this case, objects never reach the given point xf, and this corresponds that equation has no solution. Or vice versa. If equation has no solution, the point xf is to the right of U-turn point. We finished analysis of this case. Now we consider the second case for problem 2, namely when position of the point of interest xf coincides with position of U-turn point. The object moves to the right, arrives at U-turn point, and then goes back, and in this case, equation for Tf evidently has two equal roots, which are equal to time Tu, it's namely the time to reach U-turn point. Now I would like to remind you the example which we considered previously, namely problem 1. In that example, we used the following initial conditions and got the answer for Tu and Xu given here. In terms appropriate for problem 2, we have the following example. We take three initial conditions, the same as in example 1 for problem 1, and we add a location of point of interest at U-turn point, namely at 3.0 meters. So if we use these numbers in these equations, then we will see that this equation has two equal roots equal Tu. You see here the answer is 2.0 seconds. It coincides with the answer we got previously. The next case relates to the situation when point of interest is between initial point and U-turn point. In this case, the motion of the object is the following. Object moves to the right and to the left, and it passes point of interest twice. First time on the way to the right, and the second time on the way from the U-turn point. If we solve equation for Tf for this case, then we will have two positive roots, Tf2 and Tf1. Naturally, Tf2 is greater than Tf1. Let's consider an example. We select the initial conditions for the object the same as in previous examples, and for these initial conditions xu will be equal 3.0 meters and time Tu will be equal to 2.0 seconds. We select location of point of interest at xf equal 1.0 meters. So it corresponds to the position between initial and U-turn points. Solving this equation, we can find the answer. As expected, the second time is greater than Tu and the first time is smaller than Tu. We can also find the velocity of the object when it passes point xf. To do this, we can use equation of kinematics. which we used previously, and plugging in the time 2 times and values of initial velocity and acceleration, we can get the following answers. On the way to the right, x component of velocity is 2.5 meters per second, so 2 points to the right, and on the way to the left, the x component of velocity when object passes this point is negative 2.45 meters per second. So they are equal but have opposite signs because point in opposite directions. We can illustrate this by this picture. So this is V1 and this is V2. Finally, let's discuss this problem from mathematical point of view. If you solve the equation for TF and you have two positive roots, it means then the point of interest is between initial point and U-turn point. Now we consider case 4, the last case, where point of interest is located to the left of initial point. In this case, the motion of object is as follows. It moves to the right, then to the left, passes initial point, and arrives at point of interest at some moment of time TF1. If we solve quadratic equation for TF, we will find that one of the root, TF1, is positive, it corresponds to this moment, and second root is negative. So the object arrives at this point only once, because after arriving at this point it's still moving to the left and leave this point forever. Very simple situation. As an example, we consider again the initial conditions which we used previously and which lead to U-turn point at position 3.0 meters and time to arrive at this point 2.0 seconds. And we select the point of interest at -2 meters, so to the left of initial position, which is 0 in this example. After solving this quadratic equation, we will get the answer that time TF1 is equal 4.6 seconds and second time is negative 0.858 seconds. We can compare this time with time TU, time to arrive at turning point, and how we can interpret the motion. Object moves during 2 seconds to the U-turn point, then it moves back 2 seconds to arrive at initial position. It will give us 4 seconds of motion, and then 0.6 seconds to arrive at point of interest. Let's try to interpret this problem from mathematical point of view. So if we have this quadratic equation for TF, and we solve it and we obtain two roots, one of them is negative and one of them is positive, it means that the point of interest is located to the left of the initial position of the object. One can say that we missed one important case, namely that case when equation for TF has two negative roots. This case is perfectly possible for quadratic equation. But we know that we considered previously all possible position of the point with coordinate x, f, and actually we cannot explain existence of this root by some specific motion of the object and position of x, f. This means that we can assume that for considered motion, the quadratic equation cannot have two negative roots. To prove this, we will use the well-known formula for the roots of quadratic equation, and applying this formula to this equation, we will get the following answer for t1 and 2. To analyze this answer, we take into account that v0 is positive. To have two roots, the expression under the root should be also possible. And when we take here the plus sign, we will have here the sum of two positive numbers in numerator divided over positive number in denominator. It means that at least one root of this equation is positive for this situation when v0 is positive. And finally, we came to conclusion that this equation cannot have this answer. With this, we completed consideration of one-dimensional motion with constant acceleration.